go ahead and start things off. We're going to do some studying. Just preparing for my upcoming interview with one of the big name software companies. Don't want to give it away just yet. It'll be classified, but yeah. So preparing for this interview, I've been studying through Leetcode. I've been looking at Neetcode, kind of working through their problems. So for the sake of keeping everyone entertained and keeping things moving, I'm thinking it'd be great to work through just an easy problem. We're going to record it. If we get hung up, we're going to use ChatGPT. In my mind, using ChatGPT is like using a calculator for coding. It makes a lot of sense for someone to know how to use a calculator if they're doing math in today's environment. I think it's really great to know how to use ChatGPT quickly to get the answer you're looking for. So the problem, I think we're going to go through, kind of been doing a lot of linked lists lately. So let's go ahead and use, how about trees? We're going to invert the binary tree. And I'm a little rusty on my trees. It's interesting how little the interviews actually align with the things that I do day to day in my current software engineering role. I do a lot of infrastructure type work, so I'm not solving a lot of these data structure and algorithm type questions. So just kind of getting the rust off. So here we go. Number 226, invert binary tree. So given the root of a binary tree, invert the tree and return its root. So it looks like each of the sort of leaves of the tree, these are the leaves, this is the root, they're being switched. So here we're going to switch 2 and 7, and then on each of these leaves we're going to switch. So these two switch, their leaves below them switch. Everything switches one by one. Here's sort of a more simple example where you're just starting from the bottom. So I think a recursive solution is going to be the best approach to this, kind of the cleanest, most elegant solution. So when doing a recursive solution, I think it makes the most sense to start with sort of the base case. So if we're here at the end of the tree, here at the outermost leaf, then we don't do anything. So let's see. So how do we know if it's the last node there? We know that because it's both null in the left and the right. So if, let's see, root dot left equals null and root dot right equals null, we're just gonna return. There's nothing to switch there. Otherwise, we're gonna need a temp equals, so basically we're just gonna switch otherwise and then continue on down. So on down the recursive call. So we're gonna set this one to root.right, and then root.right equals root.left. It's amazing how much changing one's keyboard just totally messes things up. So we're gonna set that, and then root.left equals temp, and then we're gonna go ahead and call invert with the, let's see, the root, let's see. I'll just copy and paste this. Sometimes it's easier to copy and paste than it is to just type everything out. Okay. And let's see what happens if we run it. Where will it complain? Okay, if it's null, we just need to return null. We can't just return because it wants something to be returned. But if we create a new one, the default value is 0. Okay, there we go. And then we'll submit it. And it's accepted. Wonderful. So essentially what's happening here is we're checking sort of our ultimate base case if we're passed an empty root node is one of our cases. Then we just return null. You give it nothing, you get nothing. Then we take a look and see if this leaf that we're being passed as the root, if that's the outermost leaf on the tree, sort of like we talked about here. This would be the outermost leaf. Then see how there's no right and no left. That's how we know that this is the outermost leaf. That's our base case, so just return it. And then we're going to use sort of a placeholder node temp. We're going to swap the right and left, and then we're going to store that temp, which we're holding the value of, or the node of right in. We're going to swap that over to the left, and then we're going to call it again recursively, call this method recursively on each of those nodes, and it's just going to continue on the way down, and then it will return root. Yeah, turtles all the way down.